Hey, this is going to be a demo about the integration between EMC Appsync 2.1 to EMC XtremIO. Appsync is a software that allows us to make backups of our virtual machines, whether those running generic VMs or whether those are running databases that require application consistency backups, using self-driven SLA that are built as templates to the Appsync software. And then it also allows us to restore specific VMs while allowing them to either restore based on crash consistency or application consistency backup. So let's start. I've already installed Appsync on a Windows Server 2012. The installation itself is very trivial. It has its own PostgreSQL database. And that's it. It's just been installed. So what I'm going to do now is just log into the Appsync console. I'm going to put in my admin credentials. Appsync using a web-based interface, so it doesn't have its own client, so you can access it either locally or remotely from any VM or PC that has a browser. So the first thing it does, it pops me out that I need to add a storage array, which is what we're going to do. We're going to add an XtremIO XBrick. Adding an array is very simple. You just select the array that you want to. As you can see, Appsync supports pretty much every array that EMC produce, apart from Isilon. So we're just going to add XtremIO. We're going to give it the XMS of one of my XtremIO arrays that I'm going to use for the demo purposes. I'm going to use the tech user, although you're probably going to use the admin user, which has admin privilege of the XtremIO array. I'm going to press the next button. Okay, it just detected my array running 3.01. I'm going to press the finish button, close, and that's it. Adding the array was very simple. I can also see some information about the array. For example, what is the raw capacity of the array, how many XBricks in the XtremIO cluster. At this time of producing the demo, we support up to 6 XBricks per XtremIO cluster, so that's quite a lot. However, the brick in my lab is only one, so that's why we see only one array. The next part, we're going to add my virtual center server credentials, so Appsync will know to integrate with it. So I just went to settings, virtual center, press the add button. I'm going to give it my VC FQDN or IP address. I'm just going to use IP address for now. I'm going to give it my credentials. And it's already been pre-populated with the run discovery now, which means that it will try to detect all the ESX servers and the data stores that they connected to automatically. So that's it. It's now done. It shows me my vCenter configuration. If I hover my mouse button, I can see information like the vCenter version and such, the IP address, and whether it's connected properly. In the next part, we're actually going to configure the service plans, also known as the SLAs. Appsync has its own SLA built into the software, and we're going to discuss it in a second. But before we do, when we go to service plan, we have many options to choose. The one that is relevant for this specific demo is the VMware data centers, because we're actually going to back up VMFS or RDM devices. So we're just going to select the VMware data centers. And as you can see, there are 3 pre-populated SLA that Appsync already configured for us. Let's walk through them. Gold means that Appsync will take a local and a remote backup copy. So for example, in the use case of XtremIO, it can use XtremIO snapshots to do the local backup and a remote replication using Recover Point, which is supported with XtremIO. Silver SLA means that it will just use Recover Point to initiate a remote backup, and Bronze is going to use the XtremIO native snapshots to take a backup. We can also use Bronze with Recover Point if that's what we wish to do, to create Recover Point based journals. So what we're going to do now, we're just going to create a new template, a new SLA based on the Bronze SLA, and I'm just going to give it a name. And that's it, very simple. And if we now double click the SLA itself, we can actually see what settings have been pre-configured for us, and we can also change them. So for example, we can tell the SLA to take a frequency of the backup every day or on selected day or specific days of the month. We can set the interval of how frequent, like every day. For example, I want you to take a crash consistent backup 4 times a day or 4 times a month. Same goes for the RPO that we can select as well. You can also make it schedule or on demand. On schedule means that it's automatic. It will always do it based on the SLA that I predefine, and on demand means that there is a working job, but it not be scheduled automatically. I will actually need to initiate it manually myself. And we can also see what are the plans that this job will run. So in my case, this will start, of course, the job, then it will discover the data store, map them, and start with the copy itself. So that's it, very simple as well. Again, so if we just go to SLA, we can see the job that I've just defined. So let's now go back to the XtremIO because I want to show you something. That's my XtremIO Xbrick that we just connected to Appsync. And currently, if you can see, I have only one data store, and that's going to be the data store that we're actually going to take a snapshot from. And this is just a snapshot that I'm using for my own lab backup purposes. I'm actually eating my own dog food while using the XtremIO snapshots to back up my lab environment. But that's it. So we only have 2 volumes here, one active volume and one snapshot volume that it's not currently in use. Now what we're going to do is go to the copy management tab, and again VMware data centers. Remember that I told you that we ran the discovery, so now if I press this, we're actually going to see all the data stores that Appsync found. The one that is relevant for us is actually this one. That's the same data store that is here, and that's the data store that we're going to back up. That's also the data store that is running all of my infrastructure VMs like the vCenter, login VSI launchers and such, and we're going to use it to actually back up VMs and restore them. So how do I add a data store to an SLA? Very simple. I'm just going to press the tab next to the protect. I'm telling it subscribe to a plan and run. I can just subscribe it if I want to, and then it won't start immediately. But if I do subscribe to plan and run, it's going to subscribe the data store to an SLA and start with the backup. And so that's what we're going to do. If you recall, we created this SLA based on the bronze, so it's going to use XtremIO snapshots to do the copy. And that's it. I just press it. So now it starts with the details of what's going on. It's very interesting. What Appsync will do is actually run VMware snapshots on each VM that reside in its data store, and once it finishes, then it will run XtremIO snapshot on the volume. So it will try to make the VMs that it protects as much as consistent that it possibly can. And then by the end of the snapshot creation or by the end of the job, it will delete the VMware snapshot, so they will not just hang out there. So now we can see that it's trying to map all the VMs that are connected, and in a couple of seconds we will also see the next steps. That's it. It tells me that I'm running the evaluation license, which I do. And as we can see, it already started using the VMware snapshots to back up all the VMs that are residing on this data store. If you go back to the vCenter web interface, we can see that that's exactly what's happening right now. There's many jobs that are running running VMware snapshot on these VMs. And as we said, by the end of this run, it will actually take an XtremIO snapshot on the volume itself. So I just give it a couple of minutes to finish. Right, so if we go back to the Appsync interface, we can see that the snapshots of the VM have been done. It then took a snapshot of XtremIO from this volume, and the way that we can see it is simply over the Appsync snapshots, which is a folder that Appsync will create for us, so we'll know to distinguish between the snapshot that it created to the one that I created, for example this one. So back to the folder, if we'll open it, we are going to see the name of the vCenter, or the IP address that the snapshot was taken from, or which vCenter Appsync connected to, and then the name of the snapshot, which is this one. We can also see, if we go back to the Appsync interface, that after it created the XtremIO snapshots, it deleted all the VMware snapshots that it took from, which is exactly what we want, because we don't want these snapshots to just exist on these VMs forever and ever. So that's it. We just took a backup of the volume that are running this VM, and with all the VMs into it. In the next phase, we're going to discover how to recover a VM. We can recover one VM or more. We can recover a file from a VM if that's what we wish to do. So how do we do it? Well, there are two ways to restore a VM in terms of the management UI. You can either restore a VM from here, from the Appsync interface, or you can restore the VM directly from within vCenter. How do you do it directly from within vCenter? Well, we've got the appliance called Virtual Storage Integrator, known as VSI. It's a free appliance that allows you to do many things like create storage directly from within vCenter, provision XtremIO storage, provision VMFS, RDMs, connect to VDI brokers. But in the context of Appsync, it also allows you to get an SLA or a self-service portal that will allow the end user to restore a VM if that's what we wish it to do. So how do we do it? We go here to the vCenter tab. The appliance work with the web interface only. We go to the Data Protection System tab, and then we're going to add the Appsync server to it. We're just going to register it. How do we register it? We press the plus button. We're going to give it the name of the Appsync server. The default port is 8445. My credentials. I'm going to press the test button to see if it's working. It is. That's good. So we just added Appsync to VSI. So now we have two ways of recovering the VM from. We're actually going to demonstrate them both. So let's start with the Appsync interface. How do I restore the VM? So if you go to protected virtual machines, we will see all the VMs that Appsync protected. My vCenter contains thousands of VMs, but we only protected one data store that serving these VMs. So let's take a VM that I don't mind destroying. Let's say it's launcher 20. How do I restore it? I just stand on it and then I press the restore button. Right? And again, I have two options to restore. I can restore the entire VM or I can restore a file. We're not going to demonstrate restoring a file, but if that's what you wish to do, you need to also install another VM and run an Appsync agent on it, which will be used as a proxy server that will mount the restore VMDK file, and then you can browse the file that you want to restore from and then back to the VM or to another VM. Here we're just going to restore a VM, so again, restore virtual machine. If I have more than one backup job, I can select them from. Next. Continue to restore the selected virtual machine only, or again, maybe I want to restore some other VMs that were taken at the same time. Here we're just going to restore this one. This is an interesting part of Appsync. It's very granular in the way that you can restore it. For example, you can restore it to another virtual center if that's what you wish to do. Here we're just going to restore it to the same data center with the same vCenter. Those options are quite nice. For example, let's assume that the source VM is still there, which is exactly my case. Maybe I want to fail the restore because I don't want the restore to reside or to overwrite my source VM. The other option will be to create a new virtual machine, so Appsync will restore the VM, but it will give it a new name. The third option is unregister the virtual machine, so it will unregister the source VM, but it will not delete it. The fourth option is, and that's the one that we are going to do, is delete the disk from before performing restore. So Appsync will actually go, delete from disk the original launcher -20 VM and then restore my copy. And then the other option is delete from disk after performing restore. The last option is a bit more safer because maybe I'm not sure that I will be able to restore a VM and I want to first try to restore it, and then if I'm successful I want to delete the original one. However, in my case I'm just going to use this option, the fourth one, so it's going to delete the source VM and then it's going to restore the VM to the same original location. I'm going to press the next button. I'm going to select a host that can see this data store. So in my case, I've got two ESX servers that are running the management infrastructure, SCVDI 01 and 2. I'm just going to use one here. Next. This feature allows me to instantly restore the VM and start working it while Appsync still restoring it. But in my case, I'm just going to say no, and I want it to fully restore the VM before I'm actually starting to power it up. Next. It's going to show me all the features that I've just selected. Finish. And that's it. Here we can see again the details of the job. Validating restore. It's going to mount the snapshot to the ESX server. It's going to rescan the HBAs on those ESX servers. It's going to give the snapshot a new signature so it will not interfere with the original source volume. And it's then just going to restore the VM on the top of the existing one. So here we can see what's the steps that are currently being taken. It's just going to take a couple of seconds, so we're going to pause for a couple of seconds. We can see that it's now just going to use the XtremIO snapshots, and this snapshot volume will have to be mounted to the ESX servers. So that's also what's going to happen right now. So as we can see, it took a snapshot of the snapshot, which call it granular restore snapshot, and this snapshot will be then eventually mapped to those ESX servers. Oops, we can just see that it's already mounted. This is what we see right now, and we can see that it's even gave it a LAN ID to restore the snapshot. Very clever, directly with XtremIO and with its interface. And if we go back to the Appsync interface, we can see that it just mounted the snapshot. The next part will be, of course, to map the snapshot to the array itself. Here we can see that it starts mounting the data store to the ESX server. There you go. Back to the classic Virtual Center interface, you can see it's now resolving the VMFS volume, and in a second it will give it a snapshot prefix name. There you go. We can now see the data store that starts with snap minus, and then it's the same data store as this one, so that's a replica of this one that will be mounted as a snapshot, which will then be used to restore the VM from. We can even browse it here if we want to and see that it contains all the VMs that the original source contain. Back to the Appsync, so we can see that this data store has indeed been mounted, and it is now starting to restore the virtual machine. Before that, it will of course delete the original one as was discussed, and that's it. It just restored the VM. So after the VM will be restored, it will of course unmount the snapshot volume and then completely remove it, including its mounting and mapping from the XtremIO array as well. So if we go back to the classic vCenter interface, we can see that the snapshot volume is not connected anymore to the ESX servers, which is expected. Then it will of course delete it from the array, the snapshot of the snapshot, and then it will run a rescan on the ESX server, so we will not see a trace of the unmapped snapshot volume. Okay, that's it. We've done. We just restored the VM, and Appsync also cleaned after himself. So back to the XtremIO array, we can see that only the original snapshot now exists without the snapshot of the snapshot. So we just perform a restore operation from the Appsync GUI, but let's assume I'm just a VMware guy and I want to restore and backup everything using my portal to the world, Virtual Center, vCenter. So how do I now restore the VM? Well, very simple. If you recall, we've already connected the Appsync appliance to the VSI appliance, and now I'm in the vCenter web interface. Appsync works with the web interface only, and I'm in the virtual machine tab. So let's assume that I actually want to restore Launcher 20. How do I do it? Right click Launcher 20, EMC VSI plugin actions, VM restore. So it will now go ahead and query the Appsync server, and it will show me the same thing that I showed in Appsync before, but just in the context of Virtual Center. So for example, I only have one copy of Launcher 20, so I can only browse from one copy that I can restore from. Next, do I want to restore only this VM or maybe other VMs as well? For the purpose of this demo, I'm just going to restore Launcher 20. Next, the restore location, again I can restore to a different Virtual Center environment if that's what I wish to do. And then the other option, what I want to do with the source VM, whether I want to delete it or make it stay. So here's the original location, and I want to delete from disk before performing restore. Next, say mounting host. Next, instant restore, no in my case. And next, finish. And that's it. It's actually going to do exactly what we've done before, but using the vCenter GUI. So again, if I'm just familiar with the vCenter interface, that's exactly what it's going to do. So it just submitted the request successfully, and it will do the same thing as before. Take a snapshot of the snapshot in here, mount the snapshot volume to those ES6 servers in my management cluster, mount the snapshot volume, restore the VM form, unmount the snapshot volume, run a rescan on the ES6 servers, and that's it. That was part one of our demo, protecting virtual machines from a crash consistency perspective. In part two, we're going to show how to protect and restore VMs that are running databases. In this specific demo, we're going to restore an Oracle database that require application consistency, backup and restore. So similar to what we've done before, we're now going to take a backup out of an Oracle database that require an application consistency. So we go to the service plan tab, and we're just going to click the Oracle database one. And in this case, what's unique is that we still have the same SLOs, but the action plans of these different SLO will be different based on what the actual steps that are needed for Oracle specific workloads. Like for example, mounting the database, truncate the log files, and so on and so forth. So if we examine the bronze SLA, we can see differences between backing up the VMware volumes to the database one. So many other steps like pre-mount scripts and mount scripts and everything that you would expect when you're taking an Oracle database consistent snapshot. So we're just going to create a new SLA based on the template of the bronze built-in SLA. We're going to give it a schedule, and again we can play with the schedule whatever the way we want to. And here are the specific Oracle tasks that needs to be taken. If you work with RMAN, then there will be different steps as well, as you would expect. If I want to, I can also integrate the XtremIO snapshot with the recovery point bookmark, so I can decide whether I want to take some Oracle backup using the XtremIO inline deduped and compressed snapshot, and I maybe also leverage recovery points for some of the journals as well. Maybe offload some snapshots to another array if that's what we wish to do. So everything here is very granular in its operation. Okay, so that's our service plan. We can go ahead now and run it, and it will take an Oracle consistent backup. It's discovering the database, taking a copy, using the XtremIO snapshots, quiescing the database, and by the end of it we can see everything that was done. And if you go back to the XtremIO array, we can see all the volumes that are there for the source volume, and also including the snapshot volumes. And as we said, Appsync will create its own folder, so you will be able to distinguish between the snapshot that Appsync leverage and use it to the one that maybe us as system administrator leverage using the XtremIO unique snapshot capability. Okay, so what we're going to do now is we're actually going to mount the snapshot database that we just took back to the original database, without overriding the original database. Maybe we just want to mount some files and then see that the restore is successful, and then we can override the files if that's what we wish to do. So very similar to the VMFS data stores restore operation, we can select the job that we want to restore from. Here we have only one, so we only see one option. Whether I want to mount it on a standalone server or create an RMAN catalog entry if that's what we wish to do. What server we want to mount it to, what path we want to mount the database files to. It's a Linux server, so it's using mounting points that we can mount it to, but we'll do it to the default path, which is appsync -month. And that's it, the job started, and it's already almost finished. It mounted those RDM volumes to the ES6 server, and then of course to the VM. Because with RDM you want to mount the volumes to the VM after you map it to the ES6 servers. Did a rescan of the ES6 server, adding the RDM devices to the VM as we just explained. So the job is finished, and if we now go back to the Oracle database VM, we can see that we have the original volumes of the database plus the one that we just restored to. Again, we just mounted the restore database as opposed to just override the existing one on the top of the existing one. And that's it. That was a demonstration of backing up and restore an Oracle database that resides on VM that also require application consistency backup. I hope you enjoyed the demo and have fun with Appsync.